as the final example for an improper integral, let's consider the integral of ln x from 0 to 1. And you can see that from the graph of ln x, we have a vertical asymptote at 0. Okay, so according to the method that we mentioned, we should take the right limit of this integral, and to solve this integral we will need integration by parts. And I think I gave an assignment problem also regarding this ln x integral. So there we must take u as ln x and dv as dx. If you take it in the other way, this will not work. So if you use the integration by parts properly, then this integral can be written like this, and by solving it you can see that everything will reduce down to ln1 minus t times ln t minus 1 minus t, and ln1 is equal to 0. So the final answer will be equal to negative t times ln t minus 1 plus t. And that means the answer for this integral, but we have to calculate the limit to compute the answer for the given original integral. So the original integral will be the limit of this thing, and we found the answer for this one in the previous line, which is equal to this. Okay, so if you use, like, now it's a matter of computing the limit correctly. So to compute the limit, we first distribute the limit across these three terms, and since this one does not have a t term, it is independent of t, and you can write it as negative 1, and this is equal to 0. And for this one, you cannot evaluate the answer at once, because when t is equal to 0, then this will be 0 and this will be negative infinity, which is a indefinite situation. So if you have such a situation, we can use the L'Hopital's rule, and to use the L'Hopital's rule, we need the integral in the form of a fraction. So I write t times ln t as ln t divided by 1 over t, and for 1 over t, so then we can use the L'Hopital's rule, and the L'Hopital's rule says the same limit can be obtained by differentiating the numerator and the denominator separately. The derivative of the numerator, which is ln t, is equal to 1 over t, and the derivative of the denominator, that is the derivative of 1 over t, is equal to negative 1 over t squared. Then it's just a matter of doing the simplification. So you can see, if you do the division correctly as mentioned here, then the answer for this one will be equal to 0. Therefore, altogether this is equal to 0, this is negative 1, and this is equal to 0. Hence, the answer for the given integral will be equal to negative 1. That means the given integral, which is of an improper integral in type 2, and we have a finite answer for this one. In other words, this integral converges. And there's one more thing that I need to tell you with this calculation, that is the way you have to present your solution. Okay, see, now in this solution, for this particular problem, I have not done any any unwanted rough work within the solution. Okay, see, I have started with the problem. I have started with the given problem, and to use the integration by parts, I have mentioned it as a topic and done the required calculation, and have computed this integral separately and obtained the answer. Thereafter, in the next line, I have used the obtained result to calculate the final answer. See, now this is the way you should present your answer, especially when it comes to exams and homework. Otherwise, if you start with this problem and write the next step and then do the integration by parts somewhere in a corner, and if you rewrite the next step in the top line and then go to another calculation, so if someone starts to read it from the very beginning, it's so confusing. So please make sure to present your answer in a neat way. Okay, it's okay to use lot of papers, that's fine. Only thing is that you should leave some space in between the lines and do it properly. You don't really have to have beautiful handwriting. If you have, then it's an added advantage, but it's not a must to write it with beautiful letters, but you should present your solution in a neat way. Okay, you must keep a space in between the lines. Okay, and then follow a proper order, right? So this is the order that I did the problem. Otherwise, if you do a calculation like this and write the solution that you obtain from this calculation in the top line, then it's very confusing for the reader who reads it first time. Okay, so the way we read a solution is starting from this one. We read from left to right. Okay, so if you have written something here which you need, which you obtain from a calculation somewhere below, then it's so confusing. Okay, so please make sure to write everything in a proper order and in a neat way. Okay, by keeping some space in between the answers. Okay,